This training video covers several methods to simplify the creation of stimulus tests and a few methods to create some more powerful tests. The first method we will cover uses C# looping to execute a test script iteratively with different values. The example script I will create uses a C# loop to change an attribute at several different gears. Using UFS tools, I will read an attribute, then write the attribute to make a change, and then read the attribute again to verify the change. During the loop, I will change my gear dynamically to 3 different high-speed gears. So to do that, I'm going to use a for statement. Now this is a C# specific syntax, but I will explain it as I walk through. So for, what you have to set up is some sort of an iterator, something that this is going to loop over. And so in this case, that's going to be an integer. So I'm going to define an integer, name it I, and I'm going to set it equal to 1 initially. That's the value that you want to have the for loop iterating over. Now, how long does it iterate? This integer I is set to 1, so that's where it'll start. And if I type semicolon, the next thing I have to tell it is how long I want it to loop. Well, I want it to loop while I is less than or equal to 3. So that means as long as I is less than or equal to 3, this loop that we're creating will continue to loop. The last thing you specify is what to do at the end of the loop to my I value. And in this case, I want it to go up. So I'm just going to type I plus plus. Then it's an open curly brace, and all the code in this curly brace now, between these two curly braces, will loop over and over. I will be equal to 1 the first time. It'll then get incremented to 2. It'll then get incremented to 3. And as long as I is less than or equal to 3, this code will continue to run. So that's what we're attempting to do here. So the thing that I want to have happen first off is I want to change my power mode. So I want to set power config dot tx gear, and I want to set that equal to my current value of I. But you'll notice if I type equals I, it tells me that that's invalid. But you'll remember that the enums that we have available are all integer backed. So gear wanted to use the gear enum. So I could type gear dot, and I could select 1, 2, 3, 4, 5, 6, 7, whatever I want to do. But in this case, I want to go to gear 1 because gear 1 equals 1. And you'll see here if I go down to 1, it even tells me over here gear 1 equals the value of 1. So I can specify gear as an integer, but I just have to tell the application that what I want is actually a gear enum. So to do that, we're actually going to use what's called a cast. So to cast, you put the thing you want to cast to. So I want to cast my integer into this gear enum in parentheses. And then the value that follows that last parenthesis is the value you want to change. So in this case, that's going to be an I. So what I'm now telling C# is to take I, make it a gear, and set tx gear. So in this case, I'm going to set my gear to 1. I also need to set my rx gear. So I'm just going to copy that line, change the T to an R, and now I've set my rx gear. So now I have this power config all ready to roll. It's gear 1, fast auto by 2, rate B. I need to now actually set that by using the UniPro tools. So what I'm going to call is a method from my tools collection. But again, like I did before, just to make this less confusing, I'm going to rename tools to UniPro tools so I can see in line which one I'm calling. So we're going to make a call here to UniPro tools, and I can scroll down to my IntelliSense, hit tab, dot set power mode. And what do I want to set the power mode to? I want to set it to all this stuff that I've already configured in power config. So I just have to give it this power configuration object. So I'm going to do open paren, and you'll see that it even asks me for my power mode configuration. So I'm just going to pass in power config. So that's going to go ahead and change my power mode to HS gear 1. Now the second time this loop iterates, the only thing that's going to change is this TX and RX gear. All this will be left alone. TX and RX gear will now be set to 2, and then I can recall set power mode, and now it's going to change to HS gear 2. And the third time through, it'll change to HS gear 3. So that's just going to basically iterate change power modes 3 times. Now, each time that I change power modes, I want to go ahead and run some set of code. And in this case, what I'm going to do is just copy and paste. This is the exact same code we wrote for the UFS demo. So I'll just paste this in there. And if you didn't watch the UFS demo, I'll run through this really quickly. And we're going to go ahead and delete the write line commands, because in this case, we're not going to worry about debugging. We're just going to look at the results in the packet window. So I'm just going to remove these lines. So this is exactly what we did in the UFS demo. I'm going to use the UFS tools to read attribute 0, which is boot LUN enabled. Then I'm going to use write attribute to write that attribute to a value of, in this case, we're going to write that to a value of 1. And then we're going to read the attribute to verify that that attribute value did in fact change. So we're going to read it, read it again to make sure that the value changed. Now, because we're doing this as part of our for loop, this is going to change to HS gear 1, run this code. Then we're going to come around, use our UniPro tools to change to HS gear 2, and we're going to rerun this code. And then we're going to come around again and change to HS gear 3 and run this code a third time. So we should see this series of reads and writes happen 3 different times. Once this is done, this returns true, meaning the test succeeded. One thing we have that's new with 2.02 or higher is the ability to change the message that's written out to the application software. What I want to do is just set context dot, and it's actually called error, but really it's just the context dot error string that gets printed out. Doesn't necessarily mean that there was an error, it's just called error. And so what I'll type in is finished stimulus test. So I know that my test finished, semicolon. And then I need to tell it what type of message this is. So again, if I type context dot test error level, I can set that to this error level enum dot el, and we'll just say none. So there was no error, so it should just print the message finished stimulus test, and then it will turn true. So remember, this is new with 2.02 or higher. If you're still running an older version, you may not yet have this ability, but the rest of this should work for you just fine. The test body, where all of our code runs, passes in a couple of parameters. There's a test run context, and there's the exerciser and status toolkit. So the toolkit is passed in from the application, and that's how we were able to get our UniPro tools. But the context is the actual context of the current running test in the application. So the context gives you access to some other pieces of information. So let's go ahead and stop our debug session here. And I just want to put in a couple line breaks, and I want to type context dot. And you'll see that you can get some information about what's set up in the app. What LUNs do I have configured? What are my link widths values that are configured? What are my rate series values? My speed values? So all that information is passed in from the app. And for example, the speed value or the rate series value is passed in from what you have selected in your configuration. So in this case, the speed would be PWM gear 1, and the rate series would be A. So that allows me to look at the context of what is set in the app within my test. And that information can be helpful if I'm trying to figure out what's going on in the app as part of my stim test. And it can also just be there for reference in case you want to write a stim test to say, oh, I don't want the stim test to run at HS gear 2 for some reason. So I can check, and if this test is trying to be run at HS gear 2, I could throw an error and I could bail out of the test. You'll notice we also used that test context up in the should run method to check the device values. So that's a way that you can check the values prior to running your test. Are certain device values set in the app? And if not, you could return false, and the should run won't even allow the test to run. That could also check the speeds and link widths, like I said before, and you could do that in the should run and then bail out of your test. We saw that there were a lot of parameters on the read attribute method, for example. If I just go back to this attribute method, open paren here, those are all the attributes that you could pass in. Now they all have default values, but say that I want to pass in an attribute ID and I want to change the value of my flags from 0. So the way this ends up working is you have to specify all the values without default values. And then I can specify as many of these as I'd like, and I can stop as long as all the parameters following it have default values. So the hard way would be to say attribute is 0, comma, index is 0, comma, selector is 0, comma, HD is 0, comma, DD is 0, comma, flags 1. That's the hard way. I've had to specify 4 parameters in the middle here that I don't care about. I want them to just be their default value. So something you should get used to using, it's called named parameters. So what that means is I specify the name of the parameter followed by its value. When I do that, I can specify these parameters in any order. So rather than doing this the way I did, I could just delete all these and let's start again. And what I want to do is I want to specify that attribute ID, and you'll see it kind of gives it to me, colon, saying the attribute ID parameter is 0. Comma, now I want to specify flags. And so I can just type flags, and you'll see it even gives me in the IntelliSense flags colon, right? So flags colon 1. And so by using named parameters in this case, I can specify the attribute ID of 0 and the flags of 1, and all the other parameters will still get their default values. That's just a quick tip as you're going through and creating these test cases. When you need to shortcut some of these parameters, you don't have to specify them all if you used named parameters like we just did here. We've only touched on the surface of the power of what you can do with the stimulus tools. So I encourage you to go read the Stimulus User's Guide and also spend a little bit of time in that Stimulus API reference. And again, those can be found on the Test Editor menu, Help. You have your UniPro Stimulus Editor Manual. The UFS Stimulus Editor Manual will be up shortly. And then you have the Stimulus Editor API documentation, which will really tell you all the different methods and properties that you can run in both your UniPro and your UFS tool sets.